have as a society with fossil fuels is that we need to substitute them for the pollution problems and the CO2 emissions. What we really need is to substitute that into renewable energy vectors and also to generate them by renewable energy sources. We need to get photovoltaic, wind power, hydropower, etc. Kinds of energy sources that provide our society of energy, but the problem of all of them is that they are intermittent, so we cannot store them for long term. So we need something that really stores a lot of energy, which is like chemical bonds. Chemical bonds are perfect because you generate a material and it stays there, and this is where hydrogen takes the place.
Hydrogen is a green source of energy, and in the process of storing and extracting energy from hydrogen, the goal is to do not produce waste material at all. So it will be a perfect complete green source of energy.
The benefits of the hydrogen technology is first the independence of the fossil fuels, and the second one is that is a technology that can be used off-grid. So this means that we can generate this hydrogen in remotest places when electricity are not reached, and then we can produce this hydrogen, and with a fuel cell we can obtain electricity from this very easily. The main barriers of the widespread use of the hydrogen technology is mostly the price, which is still not very competitive in comparison with the fossil fuels, for instance, but also another problem is the storage and transportation of this hydrogen, which is still a challenge.
Compressing hydrogen, storing it, being such a small molecule, ends up with the problem that it can leak, it can go away. So this is where research comes to try to find similar products to hydrogen, but which can store energy in a more easier way. For example, in liquid state, not in gaseous state.
The solution that LEDCO proposed in this sense is to directly create this hydrogen by water splitting, but storing in the lattice of the graphene oxide. So at the same time that we are creating this hydrogen, we are storing it in this graphene oxide, which is a solid, so it will facilitate the transportation of this hydrogen. So in the first part of the LESCO project, we have developed the methodology to create a carbon-hydrogen bond, so store this hydrogen in the graphene oxide lattice. And in the second part, we will develop a fuel cell in which we can put this hydrogenated graphene oxide and obtain energy from the breakage of these bonds.
So basically we have a system composed of various atoms, carbon, hydrogen, oxygen, and we model how they evolve with time. For example, we created a different bunch of structure for the original system, and then studied how hydrogen can be absorbed on this structure and how it desorbs.
What is the goal of our project? Mainly is the desorption part, so starting to learn how to recover this hydrogen we store in the graphene oxide, mainly by light-induced means, like using laser, so that we can understand at which energies does the hydrogen start to be released. And also we are working into fabricating the prototype of hydrogen storage to graphene oxide by electrochemical means, coupling that with photovoltaics.
We are generating this hydrogen, which is directly bonded to the graphene oxide. We can dry this graphene oxide and we can transport it as a solid instead of as a very diffusive gas, which facilitates a lot the storage and the transportation of this hydrogen. And in the moment that we are going to use it, we can use a fuel cell to recover this energy in the hydrogen-hydrogen bonds.
Fuel cell, it's a cell which contains anode, cathode between electrolyte. From anode side comes hydrogen. So when we apply load, an electrochemical reaction happened and we get electricity and water as product.
So LESGO technology has many possible applications. It's in a very early stage yet, so it's possible that we end up finding many more. But for example, for long-term storage in housing, in large boats, for heavy-duty applications like mining or similars, it's really interesting because it's easy to fill a tank with this liquid and retrieve the other part that you already used, and then you just can keep on working. And we are going to try also to understand our material up to the point that we can recycle this same carbon. So we can charge the graphene and use it whenever, and the product that's released without the hydrogen, it's still graphene in water, so it should be the same product that we use in the beginning, so we're going to make it recyclable.